Ladies and gentlemen, for the next 7 minutes, I will try to give you an idea about the light jacket. The light jacket has been developed in order to counter the Ziegler-Najar disease. It's a liver deficiency whereby the bilirubin that normally is a breakdown product of the blood is poisoning the child, and finally, if there is nothing done, after 3 months it will die. What is bilirubin in fact? As I said to you, it is a breakdown product of blood. It's normally conjugated with glucuronic acid, which is in the liver enzyme to make it water soluble. If the enzyme is missing, the only alternative is phototherapy. Otherwise, it cannot be evacuated by the small bowel, which is a normal evacuation system of our corpse. The reason why this jacket has been developed is a small child that was suffering from this Ziegler-Najar disease. Solution, as I said, was phototherapy. It's a light with a specific wavelength. And at this moment, the treatment is done by a certain installation. But this installation has has many drawbacks. You have to do it in a confined space. The eyes, because of the ultraviolet rays, have to be masked. And the child has to undergo the system without clothes. There is absolutely no normal activity, and the power consumption is very high because there are very high-level lamps there. The equipment, of course, is bulky. So we have formed the following criteria for improvement. First of all, the application should be easy. There should be a freedom of movement. There should not be any personal discomfort. It should be lightweight. There should be energy saving because it's independent from an external source. And there should be no social inconvenience. And the system should be reliable and self-controlling. So we came to the following specifications: a light spectrum of 473 and 505 nanometer. The temperature, because it's close to the skin, should be maximum 30 centigrade. The radiation power on the skin should be 5 milliwatt per square centimeter. The weight, because it's a small child and has to be carried, should be maximum 500 grams. It should be totally independent from external sources. The battery exchange should be very simple. The maintenance should be simple, and the consumption, of course, has to be reduced because it's a portable system. So we had the choice of materials. We choose for the SMD LEDs, which is a new development of light generation, in the blue and the green range. We have chosen for the polypropylene as a preformed carrier. We also have chosen for the nickel metal hydride batteries because they are very safe. And we developed a special electronic circuit for the control of the total system. So we achieved the following results. The light spectrum, we got the blue spectrum of 470 nanometer. The green in 510. Temperature was maximum 30 degrees. The radiation, we even arrived at a higher figure than what was expected. We got 8 milliwatt per square centimeter. The weight was approximately 400 grams, which is very portable. And the autonomy per battery was 30 minutes. And the consumption was between 10 and 20 watts. Here you see the LEDs we have been chosen. They have about 3 millimeter. They are about 3 millimeter wide by 3 millimeter. The thickness is 1.5 millimeters, very, very small. And these LEDs have been put on a special carrier. There are 288 LEDs per element. The element is about 18 centimeters in length and 8 centimeters in width. The battery you see under there with the mini figures, it's a battery specially made of 24 volts, and the electronic circuit is very small because it's all on SMD system. Now, why could we achieve this interesting solution? Well, we were using the scientific principle of the square rule. Square rule is in the physics known giving. By halving the distance between the lamp of the light and the skin, you increase the efficiency by the square. Now, since we were reducing the normal 500 millimeter to 4 millimeter, we are increasing the efficiency of the light by a factor of more than 15,000. Here you see some important technical details. I told you that the spectrographic results were very important. Well, the red bars are the ideal, and you see that in the undergraph, the LEDs are much closer than the lamps that are used for the moment. We evaluated the system by a special bilirubin analyzer. Here you see the finished product. It's presented in a jacket, but it can also be used in a wrapping for small children, for the infants that are suffering from jaundice. Here you see the practical use of the invention. You see the small child. We got coverage from the press all over Europe. And I should say thank you for your kind attention, and I hope that this will make the life of these children much better than they are for the moment. Thank you very much.